Good morning, dear children. Today we can see some basic mathematics that is used in physics. Most of the things I think you have studied in 9th and 10th standard. In that, only the things we needed for physics, that only I will mention here. Okay. And then you can write the notes along with me. Okay. My intention is actually only to remember the things that you already learned here. Okay, let's start with trigonometry. Trigonometry. Okay, in trigonometry, you have learned a number of functions. Okay, for that here we are considering a right-angled triangle. A right-angled triangle ABC that represents a right-angled triangle. And here the angle C that is represented as theta, and this angle B that is represented by 90 degree, and here the angle is 90 minus theta. Okay, and we can name each side of this right angle triangle, and here the side which is near to this angle theta, that is side BC, that is called the adjacent side. Okay, the side BC is called the adjacent side which is near to this angle theta. Then we have here the side AB. Actually, that is opposite to this angle theta. That side is called the opposite side. The side AB, which is opposite to the angle theta, that is called the opposite side. And here we have a side AC, which is opposite to this right angle, that is called the hypotenuse. Okay, name the three sides of this right angle triangle. One is the adjacent side, other is the opposite side, and another is the hypotenuse. Okay, then using these sides we can represent these different trigonometric functions. Let's see how we can represent the function sin theta. Sin theta can be written as opposite side divided by hypotenuse. Sin theta is equal to opposite side divided by hypotenuse. That is equal to AB divided by AC. AB divided by AC. Okay, the next is cos theta. Cos theta is equal to adjacent side divided by hypotenuse. Cos theta equal to adjacent side divided by hypotenuse. That is, we can represent it as BC divided by AC. BC divided by AC. Okay, then tan theta. The next function is tan theta. Tan theta equal to opposite side divided by adjacent side. Okay, that is AB divided by BC. AB divided by BC. Okay, the next, these are the three basic trigonometric functions, that is sin theta is equal to opposite side divided by hypotenuse, then cos theta is equal to adjacent side divided by hypotenuse, then tan theta is equal to opposite side divided by adjacent side. Okay, is it clear for you? Please write the things in your note. Then we can take the reciprocal of these three functions, that is 1 by sin theta. That is the reciprocal of sin theta is actually 1 by sin theta, that is called cosec theta. Okay, the reciprocal of sin theta, that is 1 by sin theta, that is called the cosec theta. Actually, that is equal to AC divided by AB. AC divided by AB, that is hypotenuse divided by opposite side. Then the reciprocal of cos theta, that is 1 by cos theta, that is equal to actually sec theta. Okay, the reciprocal of cos theta is called the sec theta, that is equal to AC divided by BC, that is hypotenuse divided by adjacent side. Okay, the next the reciprocal of tan theta, that is 1 by tan theta, that is called cot theta. 1 by tan theta is named as cot theta, which is equal to BC divided by AB. BC divided by AB, that is adjacent side divided by opposite side. Okay, here 1 by cos theta is equal to, cosec theta equal to 1 by sin theta. Cosec theta is equal to 1 by sin theta. Then sec theta equal to 1 by cos theta. Then cot theta is equal to 1 by tan theta. Okay. Next, we can represent tan theta as sin theta by cos theta. Tan theta equal to sin theta divided by cos theta. Next, cot theta equal to cos theta divided by sin theta. Okay, tan theta equal sin theta by cos theta. Then cot theta equal to cos theta divided by sin theta. Okay. And the next is sin square theta plus cos square theta equal to 1. I think you know sin square theta plus cos square theta equal to 1. From this we can write sin square theta is equal to 1 minus cos square theta. Sin square theta is equal to 1 minus cos square theta. The next is cos square theta is equal to 1 minus sin square theta. Okay, sin square theta plus cos square theta is equal to 1. The next is sin square theta is equal to 1 minus cos square theta, and cos square theta is equal to 1 minus sin square theta. Okay, have you got it? And the next is we can write sin 90 minus theta. What is the value of sin 90 minus theta? Actually it is cos theta. What is the value of sin 90 minus theta? It is cos theta. Then cos 90 minus theta is actually sin theta. Cos 90 minus theta is what? Sin theta. Okay. Sin 90 minus theta, that is actually cos theta, and cos 90 minus theta, that is actually sin theta. Next we can see the value of some angles of sin, cos and tan. Okay, and here we can represent sin 0. What is the value of sin 0? That is 0. Okay, the value of sin 0 is 0. Then what is the value of sin 30? Actually it is 1 by 2. The value of sin 30 is 1 by 2. Then sin 45. The value of sin 45, that is 1 by root 2. Then the value of sin 60, actually that is root 3 by 2. Then the value of sin 90, that is 1. Okay, the value of sin 0 is 0. Then the value of sin 30 degree, that is 1 by 2. The value of sin 45 degree, that is 1 by root 2. Then the value of sin 60 degree, that is root 3 by 2. Then the value of sin 90, that is 1. Okay, the next about cos. The value of cos 0 is 1. The value of cos 0 is actually 1. These two are very, very important. Okay. Then the value of cos 30, that is root 3 by 2. Then the value of cos 45, that is 1 by root 2. Then the value of cos 60, actually that is 1 by 2. Then the value of cos 90, that is 0. The value of cos 90 is 0. Okay, the value of cos 0 is 1. The value of cos 30, that is root 3 by 2. Then the value of cos 45 degree, that is 1 by root 2. Then the value of cos 60 degree, that is 1 by 2. And the value of cos 90 degree, that is 0. Okay. The next comes tan. The value of tan 0, that is 0. Then tan 30, that is 1 by root 3. Then the value of tan 45, that is 1. Then the value of tan 60, that is root 3. And tan 90, that is not defined. Okay. The value of tan 0 is 0. Then tan 30 degrees 1 by root 3. Then tan 45 degree, that is 1. Then tan 60 degree, that is root 3. And tan 90 degree, that is not defined. Okay, is it clear for you? Okay. Let's see the units that is used to measure angle. Okay, measuring angle. We can use degree. Okay, you know that thing. Degree, or also we can use radians. Okay, we can use radian or degree for measuring angle. Okay, and here 180 degree, that corresponds to pi radian. Okay, 180 degree corresponds to pi radian. So 90 degree corresponds to pi by 2 radian. Okay, 180 degree, that corresponds to pi radian, and 90 degree corresponds to pi by 2 radian. Actually, this is the relation between degree and radian. 180 degree corresponds to pi radian. Then 90 degree corresponds to pi by 2 radian. Okay. The next, here we can consider a circle of radius r. Okay, here we can consider a circle of radius r. Then we can make a line at an angle of theta. Okay, at an angle of theta from this radius, we can draw another line. Okay, and here we got an arc here having length L. Okay, here the radius is represented as R, then the angle is represented by, that is the angle seep out by this radius, that is represented by theta, then this much arc length, that is represented as L. Then we can connect these three things by an equation, that is we can write angle is equal to arc length by radius. Angle is equal to arc length divided by radius. Okay, angle is equal to arc length divided by radius. So we can write theta is equal to L divided by R. Theta is equal to L divided by R. Angle is equal to arc length divided by radius. So here angle theta is equal to arc length is L and radius is R. So theta is equal to L divided by R. Okay, that is about the trigonometry. Okay, actually only this much things only we need in physics. Okay. The next mathematical tool that we used in physics is actually differentiation. Okay, differentiation. Actually, it is very, very important. Listen carefully. Okay, actually, the differentiation that plays an important role in physics because it measures rate of change. Okay, the tool differentiation that plays an important role in physics because it measures rate of change. Okay, because it measures what? Rate of change. Here we have two important words. One is rate and another is change. Okay, one is rate and another is change. Let's talk about change. We can consider first change. Okay, then you know the physical quantities, they are of two types. Physical quantities. Okay, one is constants. Then another is variable. Okay, one is constant and another is variable. Let's talk about variables. Okay, let's consider variables. Then you know the constant that does not change. Constant means that quantities does not change. Variable means that undergoes a change. Okay, variable means that undergoes a change. Here the constants does not change. And when we consider variables, for example, let us consider x. X is a variable. For example, we consider a variable x. That means x varies. Okay, then before x, we put x delta. Before x, when we put delta, this is actually called delta. Actually, it is used to represent the change. Okay, you know, the variable undergoes change and that change is represented by delta. That change is represented by delta. But delta x, that indicates change in x. Change in x. Okay, delta x, what does this mean? Change in x. Then what kind of change? Actually, it is a big change. Okay, actually it is a big change. So, here we are considering a variable x. Variable means you know, it undergoes a change. Okay, so if we represent or if we put delta before x, we can call it as delta x. Okay, we can call it as delta x. Then what does this mean? Actually, change in x. That is, change in x, that is represented as delta. Then what kind of change? Actually, it is a big change. It is a big change. Then we can represent it in another way as we have a variable x and before x we can put d. So actually dx. How we can read this as d of x. Actually it is also change in x. dx means what? It is again change in x. Then what kind of change it is? Actually it is a small change. Okay, so a big change in the variable x is represented as delta x, and a small change in the variable x, that is represented as dx. Here d is not a letter, actually it is an operator. It is an operator like sine or cos. Okay, we cannot separate this d from here. For example, actually it is like this. We have a box, we can name this as d, and we can put x inside. Okay, we cannot separate these two. Okay, it always remains together, dx. Okay, so dx means actually small change in x. Okay, dx means what? Small change in x. We cannot separate this d and x. It always remains together. Okay, so here we are considering a variable x. The change in variable x that can be represented by two ways. So one, we can use delta x. In another way we can use dx. But delta x means change in x. Actually it is a big change. Then what about dx? Dx is actually change in x. Actually it is a small change. Okay, let us consider an example. Suppose if the variable is x and this variable that varies from 4 to 6. Okay, the variable that varies from 4 to 6. Then what is the change here? Actually it is 2. Okay, here the change is 2. Is it a big change or a small change? Actually it is a big change. So we can represent it as delta x. Okay, delta x equal to 2. Okay, here the x varies from 4 to 6. So its change is represented as 2. Actually it is a big change. So we can write delta x equal to 2. Suppose if x that varies from 1 to 2. Okay, suppose if it varies from what? 1 to 2. Okay, then what is the change here? Actually it is 1. So we can, is it a big change or a small change? Here also it is a big change. So we can represent it as delta x equal to 1. Okay. Next, we can consider another example. If x that varies from 0.00001 to 0.00001. If x varies from this value to this value, is it a big change or a small change? Actually, it is a small change. So we can represent it as dx. Okay, dx, that is a small change in the value of x. It represents a small change. Then we can also represent dy. What does this mean? Dy means what? A small change in y, that is represented as dy. A small change in y, that is represented as dy. Then what is dt means? What is dt? It is a small change in t. Actually it is a small change in t. Okay, dy means small change in y. Then dt means small change in t. Okay, next we are considering d of 4. What is its value actually? D of 4 means what? D of 4. D4 means, you know what is D? Actually it represents a change. D represents a change. Okay, change of 4 means what? Actually, you know, 4. Actually, it is a number. It is not a variable. It is mere a number. Okay, so it is a constant. So its value is d of change in constant. You know what is a constant? It does not change. So d of 4 means what? It is 0. D of 4 means 0. Also d of 3. It is also 0 because it is a constant. It does not change. So we can represent d of 3 as 0. So in generally we can write d of constant is equal to 0. This is very important. D of constant is equal to 0. D of constant is equal to 0. Okay, that is about change. Next, about the rate of change. Okay, the next comes rate. Actually, rate of change means change in one quantity with respect to another quantity. Okay, that is called rate of change. Change in one quantity with respect to another quantity. That is called rate of change. Suppose when we consider the variable y and the change in y, that thing can be represented as dy. Okay, that thing you know. The change in y is represented as dy. Then what is next? We consider another variable x. Then what about the change in y? Sorry, change in x, that is represented as dx. Okay, the change in y, that is represented as dy, and the change in x, that is represented as dx. Okay, so the rate of change of y with respect to x, how we can write the rate of change of y with respect to x, that thing can be represented as change in y divided by change in x. Okay, change in x. Rate of change of y with respect to x. Rate of change of y with respect to x can be written as change in y divided by change in x. You know what is change in y here? Dy. And what is change in x here? Dx. So, here we got dy by dx. Okay, here we got dy by dx. This can be read as change in y or the rate of change in y with respect to the change in x. Okay, dy by dx means the rate of change of y with respect to the change in x. That is actually represented as dy by dx. We can also represent dy by dt. What does this mean? Dy by dt, rate of change of y with respect to change in time, t. Okay, rate of change of y with respect to change in t. Also we can write dx by dt. What does this mean? Dx by dt, rate of change of x with respect to rate change of t. Okay, also we can write du by dv. What does this mean? Du by dv, rate of change of u with respect to change of v. Okay, actually the process of finding this ratio, that is called differentiation. Okay, so actually differentiation measures the rate of change. Okay, differentiation measures what? Rate of change. Okay, the process of finding this ratio, that is the process of finding dy by dx, the process of finding dy by dt, the process of finding dx by dt is actually called differentiation. Okay, and this ratio dy by dx, that is called derivative. That is called derivative. Okay, the dy by dx, this ratio is called derivative or differential coefficient. Differential coefficient. Okay, here we got a ratio dy by dx which is called derivative or differential coefficient. Okay, that is the process of finding or measuring the rate of change, that is called differentiation, and the ratio, okay, that ratio is called derivative, okay, or differential coefficient. Here dy by dx, what does this mean? Dy by dx, actually it measures the rate of change of y with respect to the change of x. And here dy by dt, that measures the rate of change of y with respect to t. And here dx by dt, that measures the rate of change of x with respect to time t. Okay, and this process of finding this ratio, that is called the differentiation, and the ratio be obtained, that is called the derivative or differential coefficient. Next, we can see how we can calculate dy by dx. How we can calculate dy by dx. Okay, all of you know what is dy by dx. Is it clear for you? What is dy by dx? Rate of change of y with respect to change in x. That is actually called dy by dx. Next, we are going to discuss how we can calculate dy by dx. dy divided by dx. Okay, dy by dx. For that, we are considering a simple case. Let y equal to 4. Let y equal to 4. Next, we have to find dy by dx. So, we can write dy by dx is equal to d by dx. So, we cannot cancel these two d's because it is not letters. It is an operator. So, we cannot cancel. Okay. Then instead of y, we can write d4. Okay, d of 4. Already you know what is d of 4. Actually, it is a constant. So, d of 4 equal to 0. 0 divided by dx, actually, which is 0. Okay. Is it clear? Then next we can consider another example. Y equal to x. Okay, here y and x are variables. So, y equal to x. Suppose if we increase x by dx. Okay, if we increase or if we change x by dx, that is x increases by dx. Now what is x now? X equal to x plus dx. Okay. If x increases by x plus dx, then what about the change in how this y changes? Then y automatically changes as y plus dy. Okay, y changes as y plus dy. Okay, then we can let it equation number 1. Then we can substitute here y as y plus dy. Then instead of x we can write x plus dx. Okay. And here we have the relation y equal to x. We have to find dy by dx. Okay, that is change of y with respect to x. For that, we increases x by dx. We increases x by dx. So, x is now x plus dx. Okay, so here x increases by dx. So, automatically y also increases by y plus dy. Okay, here this we name this equation as 1. Then we can substitute these two values in 1. So y plus dy equal to x plus dx. And equation 1, what says equation 1? Y equal to x. That is y equal to x. So we can cancel these two because y equal to x. So here we can write dy is equal to dx or dy by dx equal to what? 1. Okay, dy by dx equal to 1. Okay, see, so we got the value dy by dx as 1 if y equal to x. Okay, listen it. Here, the value of y equal to x, so we got the value of dy by dx as 1. Next, we consider the function y equal to x square. Y equal to x square. We have to find dy by dx. Okay, if y equal to x square, then we have to find dy by dx. Okay, and here suppose if we increase x by dx, so we can write x equal to x plus dx. Okay, x equal to x plus dx, or x becomes x plus dx if we increase x by dx. Then what about the change y? Y is equal to y plus dy. Y becomes y plus dy. Let it equation number 1. Then we can substitute the values. y plus dy is equal to x plus dx the whole square. Okay, x plus dx the whole square. Here we have the relation y equal to x square. We have to find what? Dy by dx. We have to find dy by dx. Suppose if we increase x by dx, then x becomes x plus dx. Then automatically y becomes y plus dy. Then we can substitute these two values in equation 1. So y plus dy equal to x plus dx the whole square. Actually this is in the form of a plus b the whole square. You know that a square plus 2ab plus b square. Similarly we can write x square plus 2x dx plus dx square. Okay. X square plus 2x dx plus dx square. You know, d actually represent a small change. Okay, d actually represent a small change. And when we multiply dx into dx, that approaches 0. Okay, dx is very close to, actually dx is close to 0. And when we multiply once again, it is very close to 0. See that? So we can neglect that term. Okay, so we can neglect this dx square. And also you know what is actually y equal to x square. Y equal to actually what? X square. So we can cancel these two because y equation 1 says what? Y equal to x square. So we can cancel y and x square. And remaining thing actually it is dy. Okay, dy is equal to actually what? 2x dx. dy is equal to 2x dx. From this we can write dy by dx equal to what? 2x. dy by dx equal to 2x. Okay. You know the first question, first example, remembering the first example, d by dx of 4, actually that is equal to 0. The next d by dx of actually x, that we got as 1. Here it is d by dx of x square, actually it is 2x we got. Actually, okay, d by dx of constant, that is equal to 0. Then d by dx of x, that we got as 1. And next here d by dx of x square, that thing we got as 2x. Okay, and next actually d by dx of x cube, like that it will continue. And here it is too lengthy and we take a lot of time to solve this one. Actually this thing at all, too many steps, that thing you don't want in physics. Okay, actually you did in maths. So in order to find this derivative, we can use a simple equation. We can use a simple formula. Instead of doing in such long steps, we can use a simple formula or we can use a simple equation. Okay, and suppose if y equal to x raised to n, if y equal to x raised to n, then we can write d by dx of x raised to n, d by dx of x raised to n as n into this power into x raised to n minus 1. This is very important relation, you have to study. Okay, d by dx of x raised to n, that is equal to n into x raised to n minus 1. Here this power n, then x raised to, we have to less this power by 1. So we got d by dx of x raised to n equal to n into x raised to n minus 1. Okay, here we are considering here for example y equal to x square here. Then we can find this d by dx of x square using this equation. How we can find here instead of n, what is here? 2. Okay, then x raised to, instead of n, 2 minus 1. So we got 2x. That thing we got in the last problem. Okay, there are too many steps involved there. Instead of that, we can use this simple formula to find the derivative. Okay, so Here the answer is 2x. Okay, so we have the relation, very very important equation, d by dx of x raised to n into x raised to n minus 1. Next you can use, okay, you can work out this one, y equal to x cube or y equal to x raised to 4. Everything you can work out. Okay, I have to study this equation, d by dx of x raised to n equal to n into x raised to n minus 1. Okay, apart from this, we have two more equation also there, d by dx of sin x. Okay, d by dx of sin x, that is actually cos x. Okay, d by dx of sin x equal to cos x. The next, d by dx of cos x, that is actually equal to minus sin x. Okay, d by dx of cos x is equal to minus sin. So we have the three equations in differentiation, that is d by dx of x raised to n equal to n into x raised to n minus 1, then d by dx of sin x, that is equal to cos x, then d by dx of cos x, which is equal to minus sin x. These are the three important equations that are frequently used in physics actually. Okay, d by dx of x raised to n, that is equal to n into x raised to n minus 1, d by dx of sin x, that is differential of sin x, that is equal to cos x, then d by dx of cos x, that is equal to minus sin x. The next mathematical tool we used in physics is actually the integration. Okay, actually it is the reverse process of differentiation. Okay, actually it is the reverse process of differentiation. You know what is differentiation? Actually, in differentiation, we have a value. From that, we calculated the rate of change. Is it? Okay. We have a value here, and from the value, actually, we calculated the rate of change. That is the process differentiation. But in integration, actually, from the rate, we calculated the value. This is actually integration. Okay, so we can say the reverse process of differentiation is actually the integration. Actually, in differentiation, we measure the rate of change, but in integration, we measure the value. We can measure the value. That is the difference between these two. Okay, and integration, we measure the value, but in differentiation, we measure the rate of change. And here, for representing the integration, we are using a symbol. Actually, it is an elongated S. Elongated S. Actually, this symbol is this is actually called integral. Okay, this symbol that actually represents the process of integration. Okay, here also we are using certain equations to find the integral value. For that, we are using certain formulas. Okay, suppose we have a function y equal to x raised to n. Okay, then you know the equation for differentiation, dy by dx equal to n into x raised to n minus 1. This is the equation used in differentiation. But then how we can integrate this? For that we are using, that is integral y dx, that is equal to integral, instead of y we can write x raised to n dx. Okay, then what is the value of integral x raised to n dx? What is the value of integral x raised to n dx? Actually it is x raised to n plus 1 divided by n plus 1. Okay, we have to write x here, then its power increases by 1. Increase the power by 1. So we got n plus 1. And divided this by the new power, that is n plus 1. That's all. Okay, that is integral of integral. This is actually an important formula. Okay, integral x raised to n. What is the value of integral x raised to n dx? It is x raised to n plus 1 divided by n plus 1. Integral x raised to n dx equal to x raised to n plus 1 divided by n plus 1. Okay, we can do an example here. find the value of x integral x dx. Integral x dx. Okay, we can use this formula, x raised to n plus 1 by n plus 1. Here what is x n here? What is the power of x? That is 1. So n is equal to 1. Then we can apply this equation, x raised to n plus 1, that is 1 plus 1 divided by 1 plus 1. Actually it is x square by 2. That is the value of integral x dx. Okay, actually in maths we are adding a constant of integration plus c here. But here we ignore it. Okay, there actually is there, but in physics we don't want to add this constant of integration. Okay, the next we can apply integral of x square dx. Okay, this the application of this equation actually come in your derivation. That we later sections we can see that at all. Okay, integral of x square dx. What is its value? Using this formula, we can find out integral x square dx. That is x raised to n plus 1. Here what is the value of n? 1. Sorry, the value of n is 2. Okay, so x raised to 2 plus 1. Okay, x raised to 2 plus 1 divided by 2 plus 1. That is x cube divided by 3. Okay, actually this is the value of integral x square dx. Okay, so in all these cases actually we have find out the values. Okay, that is the process of actually what? Integration. Okay, and is it clear for you? Okay, actually this is the first formula that we use in integration, and the next formula that you have to remember is, first thing I will write here, integral of x raised to n dx equal to x raised to n plus 1 divided by n plus 1. Then second is integral of sin x dx. This is actually the standard formula. Integral of, what is the value of integral sin x dx? Actually it is minus cos x. It is minus cos x. Okay, and the third equation is integral cos x dx. Actually it is sin x. Okay, integral of cos x. What is the value of integral cos x dx? That is equal to sin x. All of you know all these formulas in your notes? Okay, these are the basic formulas that we used in integration. Okay, the first is integral x raised to n dx equal to x raised to n plus 1 divided by n plus 1. Okay, integral of next is integral sin x dx equal to minus cos x. The next is integral cos x dx equal to sin x. Okay, integral x raised to n dx equal to x raised to n plus 1 by n plus 1. Integral of sin x dx equal to minus cos x. The next integral cos x dx equal to sin x. These are the three important formulas that we used in integration. Okay. Okay, that is about the basic mathematics that we used in physics. Okay, study well children. That is the end of today's class. Thank you.